Okay, so this is, I'm going to go over the support for section 2.4. Now, there's a bunch of fraction work at the beginning, and remember, we are getting more and more comfortable now with doing this fraction work in our calculator. Okay, so I'm going to write each problem on the board, but then for the most part, I'm going to show you how to work them in your calculator. Like number 1 says negative 35 over 16 minus negative 7 over 16. Okay, the good thing about this one is that they do have the same denominators. Okay, I think what this problem is want you to focus on is this right here. Okay, because if you are subtracting a negative number, that is the same exact thing as saying plus, right? Minus a negative is the same thing as saying add. So negative 35 over 16 plus 7 over 16. Okay, again, I can just simply type that in my calculator. But when you're adding and subtracting with the same denominator, that denominator is just going to come over. So now all you need to figure out is what is negative 35 plus 7. So again, I'm just going to type that in my calculator. Negative 35 plus 7 gives you negative 28. So now I have negative 28 over 16. Now your answer needs to be in its simplest form, right? So if I wanted to make sure that was in simplest form, I would do negative 28 divided by 16, get its decimal, and then remember our friend, math, enter, and that'll reduce that negative 28 over 16 for you to negative 7/4. So that would be the reduced answer. I could have, at the very beginning of this, typed in exactly what the problem said into my calculator. I have negative 35 over 16. So I'm just typing in that fraction. Then I'm going to type in exactly what it says, minus, so that's the minus button. Then just like that, I'm going to do an open parentheses, negative 7 over 16. So remember, I've typed in the minus button, but inside here, that's a negative 7 over 16, close. So you'll notice that my calculator shows exactly what the board does. There's your decimal. And again, math, enter it. So negative 7 over 4. So if you wanted to type that in exactly how it was written from the get-go, you can type in exactly what it says into your calculator. Okay, let's look at number 2. Okay, number 2 also is subtracting a negative. So you've got negative 1 over 16 minus negative 1/8. Okay, so this one would take a little bit more work. If I was going to do it by hand, I would still change it to add. But then before I will be able to add those two fractions together, I would have to get a common denominator, right? The last problem, the denominators were the same. This one's not, which means I would have to go through all that. And you know what? I just don't want to do that when I can make my calculator do it. So type in exactly what it says. So I need negative 1 over 16. So just negative 1 over 16. Then the minus. Then the open parentheses, and then a negative again. Negative 1 over 8. Again, calculator says the same exact thing as the board. Enter. Since it is a decimal, math, enter it to get 1/16. All All right, number 3 says negative 1/3 minus 4/5. Again, I'd have to get a common denominator before I could subtract that, so I'm just going to punch it in. Negative 1/3 minus 4/5. Minus 4/5. Now, and we talked about this a little bit on the last class. Anytime you want to put parentheses around your fractions, it's not ever going to hurt that. Okay, it's not ever going to hurt to put parentheses around your fractions. So math, enter that to get negative 17/15. All right, number 4. Now we're getting into multiplying fractions. So we've got negative 4/5 times 7/3. Now, the good thing about multiplying fractions is that's easier because you don't have to have a common denominator to multiply fractions just when you're adding and subtracting, okay? But when I am multiplying, all you do when you're multiplying is go straight across in the top and straight across in the bottom and then reduce your answer if it reduces. So if I did this one, sometimes on a problem like this, it may just be easier to do it by hand. Negative 4 times 7 gives me negative 28. Straight across on bottom, 5 times 3 is 15. And then if you wanted to check yourself to make sure it didn't reduce, just type in your answer. Negative 28 divided by 15. Get your fraction, your decimal. And then math, enter it. So you'll notice I still have negative 28/15, which just means that was in its simplest form. I can't reduce that fraction. All right, number 5, you have negative 2 times negative 3/2. Okay, if you did want to do it by hand, you would think of this negative 2. If it's a whole number, that means it's over 1. So you can still use that rule where you just go straight across in the top and the bottom. Negative 2 times negative 3 is positive 6, right? Because a negative times a negative is what's going to turn it positive. In the bottom, I have 1 times 2, which is 2. And this one will reduce, right? Because you can divide 6 by 2. 6 divided by 2 just gives me 3. And again, if you just want that fraction practice in your calculator, you could have typed in exactly what the problem said, which is negative 2. And then it has open parentheses, negative 3/2, close. Open parentheses, negative 3/2, close. There's your answer, right? Because if I did negative 2 and I started an open parentheses, that's telling your calculator just the same thing as we did here. It's telling me, since I didn't put a plus or minus in between here, it's telling me to multiply those two things together. Okay, we're going to look at number 6 and number 7 together. Number 6 says divide 5/0. Number 7 says divide 0/-15. Here's the difference. If your 0 is in the bottom of your fraction, you cannot divide by 0, even if you tried to do it. And you did 5 divided by 0. Look at what your answer is going to tell you. It's going to say error. You can't divide by 0. Okay, so this was what is called, we call it undefined. Okay, 0 in your numerator. So let's try that one. 0 divided by negative 15. Well, look what that one gives you. That one does give you the answer. It is 0. 0 in the numerator just means your answer is going to be 0. There is a difference. This is undefined. 0 in the bottom is undefined. 0 in the top is 0. That was 6 and 7. All right. Now, these next two problems, what they're trying to say, so this says find the reciprocal. The reciprocal of a number is simply flipping it upside down. The word it's going to turn it upside down. You don't change the sign. You don't do anything else. You just flip your fraction upside down. So on number 8, it says the reciprocal, find the reciprocal of 17 over 8. Well, the reciprocal of it is 8 over 17. That's its reciprocal. All right, number 9, same thing. Says find the reciprocal of negative 15 over 7. You just flip it upside down to negative 7 over 15. Okay, the next several problems are dividing fractions, which is the whole reason we needed to go over this topic right here, the reciprocal topic, because when you are dividing fractions, that is the same thing as saying you're going to multiply by the reciprocal. So before you do anything else, you flip that second fraction. So like on number 10, it says negative 2/7 divided by 7/5. So, like I was saying, division is the same thing as, if I would have to do this negative 2/7, turn the division to multiply, and turn this upside down to 5/7. So again, division of fractions means to multiply by the reciprocal. Multiplying straight across the top and bottom. Again, I can type this in if I wanted. Negative 2 times 5 gives me negative 10. On bottom, 7 times 7 gives me 49, and that doesn't reduce. Okay? You can actually even type it in. If we wanted to just do calculator all the way through this, my original problem says, now, since I am doing fraction divided by fraction. And when we type in fractions in our calculator, how do we make those fraction bars with division symbols, right? So I am going to start putting, if I'm doing a bunch of division symbols in one problem, like I would have to here, I'm going to start putting parentheses around my fractions just because I think it's going to make it work better. So I'm going to put that in my calculator. So open parentheses, negative 2 over 7, because then I got another divided by, right? That's the actual division that I'm doing, this division, and then another fraction. So open parentheses, 7 over 5. Crazy decimal. Math, enter, enter. Same thing, negative 10 over 49. All right, number 11 is another division of fraction. I'm just going to do this one in the calculator. Let's see, I've got negative 12 over 5. Divided by negative 3 over 20. I'm going to punch that in my calculator. So again, if I'm dividing two fractions, I'm going to put them both in parentheses in my calculator. So I've got negative, excuse me, sorry about that. Open parentheses, negative 12 over 5. So negative 12 over 5, close. Then the divided by, the actual division that I'm going to be doing. So divided by, again, open parentheses, negative 3 over 20. So there's my negative 3. And again, to make the over, I do the division again, 20. And close it. Uh-oh. 20, close. So again, just like I have on the board. When I do that division, it gives me 16. All right, number 12 says divide if possible, but look what it gives you. It gives you a problem like this. It says 110 over negative 11 plus 11. Well, what is this? What do you get if you put those two numbers together? What is negative 11 plus 11? It is 0. So it doesn't even really matter what this top number is, because remember what happens if 0 is in the denominator, it is undefined. Okay, now getting into number 13, it says simplify by removing the parentheses and collecting like terms. So you've got P plus, and then open parentheses, 8P minus 73, close. Okay, so what it wants you, how do you remove parentheses? Just like you always do, you multiply what's bumping up against it. This P is not bumping up against this parentheses. There's a positive separating them. So it's like a positive 1. That's what you're distributing to remove those parentheses. This P just comes down. Now, when you're multiplying, when you remove these parentheses, actually nothing in here changes, right? Because if you multiply it times positive 1, it just stays what it is. So you're just going to have plus 8P minus 73. So now the parentheses are gone. You can combine the like terms, which are these P's, right? If they're separate terms, but they have the same letter, you can write them together. Just it's like putting all your eggs in one basket. We're going to put all our P's in one basket. If you don't see a number in front of your letter, it's automatically a 1. So this is 1P plus 8P, which is 9P. Bring down the minus 73. Right, number 14 is the same kind of problem, but instead of a plus in front of the parentheses, it's got a minus. See, I've got 4D minus 7 minus, open parentheses, 6 minus 7D. So again, you're going to distribute what's bumping up against the parentheses. So this time, what the minus 7 isn't, this is what's bumping up against it. That's what you're distributing. So you think of it as a negative 1 right there. Okay? This other stuff is just going to come down. This 4D minus 7. Uh-oh. Comes down. I'm going to distribute this negative 1. So that's going to turn that into a negative 6. It's going to turn this into a positive 7D, right? Because a negative times that negative turns it to positive. So now let's put our eggs in the same basket. This is a D, and this is a D. So there's no reason to write those two terms separately since they're both D's, and I can put them together. 4D and 7D gives me 11D. Now I can also put these together, right? Because they're just plain numbers. If If you wanted to type that in, what would you tell your calculator to do? -7 minus 6, which would give you -13. Right, number 15. So, removing parentheses. What's bumping up against this one? The negative. Bumping up against this one is the positive. So that's what I'm distributing there. This -5x will just come down. Distributing a negative changes sign, so it's going to change this to a positive 6z and this to a -5. Distributing a positive doesn't change anything at all, right? Because when you multiply stuff times +1, it doesn't change it. So that's still just going to be a positive 12x and a -7. So let's put same eggs in same baskets. Let's see, here's an x. Are there any other x's? There's an x. So those x's you can put together. I've got a -5 plus 12. So together I've got 7 x's. Okay, let's see. Are there any other z's to put with that one? When I'm looking through here, I don't see any more z's. So I just bring that one down, plus 6z. But I do see that's a plain number and that's a plain number. So I can put those terms together. When I put a -5 with a -7, it gives me -12 or -12. So that's how you combine like terms. All right, looking at number 16, I've got -3 times 2a plus 6b. So again, we're going to distribute, which means multiply everything inside the parentheses by what is bumping up against it, which is a -3. -3 times 2a. So -3 times 2 gives me -6a. So now I'm multiplying the -3 times the positive 6b. -3 times positive 6 gives me -18b. When I get done, once I get done with distributing, with that multiplying, I do look. The next thing I always look for after I remove parentheses like this is to see if there's any like terms to combine. But you can't combine an A with a B because they're not like terms. All right, that was 16, now 17. We've got 19m times n plus p minus q. Same stuff. So let's see what I have here. 19m times n. When you multiply two letters together, they just hook together. So this 19m times n just gives me 19mn. Plus, same thing's happening. When I multiply these, that p is just going to hook onto it. 19m times p gives me 19mp. in the last one. So minus this time, 19m times q. So again, multiplying is just going to hook them together. 19m times q gives me 19m cubed. So when I'm looking for like terms, if you're a like term with an mn, you've also got to be an mn. You can't combine an mn with an mp. If you're like terms, all your letters got to be the same. So there isn't anybody that I can put together because they're all different kinds. This is an MN, that's an MP, and that's an MQ. So they're all different kinds of terms. So there's nothing you can do here. Okay, before we get into the rest, let's go over real quick what the exponent rule is. Like if I'm multiplying an x times an x, that's when I get x squared. Multiplying x's changes exponents. So the reason this is x squared, it's actually because when you are multiplying x's, you're going to add their exponents. So when you see a letter, but if it doesn't have an exponent, it's automatically a 1, right? There's a lot of understood ones in math. So what actually happened here is when I multiplied these same letters together, I added their exponents. So that's why it turns into x squared. So same thing here. If I have x to the 5th times x to the 4th, that's going to give me x to the 9th. Okay, so now moving into number 18, you've got 2s to the 3rd times 5s. Okay, that rule, when you're multiplying the same bases, you add their exponents, is just an exponent rule. You still multiply 2 times 5 like you always have. 2 times 5 gives me 10. S to the 3rd times S, right? Because they both have S's. So when I'm multiplying those S's together, I'm going to add their exponents, which means you want to see this, right? You want to see that S has a 1 exponent. So if I have S to the 3rd times S, that's going to give me S to the 4th. So 10s to the 4th. The 2 times 5 gave me the 10. S to the 3rd times S gives me S to the 4th. Number 19, you've got 2m times negative 2m squared into the 4th. So let's see. First of all, I want to make sure anytime I'm multiplying and I go through and I see any letters that don't have an exponent, I just want to remind myself that there's a 1 there. So let's see. Do the number part first. You've got 2 times negative 2. So that gives you negative 4. Here you've got m to the 1st times m to the 2nd. So if I multiply those m's, I'm going to add those exponents to get m to the 3rd. Now, this one doesn't have any n's that I'm multiplying with this n, which means that exponent doesn't change, right? There's not an n here to add exponents with, so it just stays n to the 4th. So again, 2 times negative 2 gave me the negative 4. M to the 1st times m to the 2nd gave me m to the 3rd, and then it just brought down the n to the 4th. All right, it looks like the rest of these problems are over what is called FOIL, which is actually an acronym. And this acronym goes with anytime you are multiplying what is called two binomials together, let me show you what that looks like. 4w plus 3f times 4w minus 3f. So what I mean by multiplying two binomials together, okay? Since these parentheses are bumping up against each other and there's not a plus or minus in between them, that means it wants me to multiply those two parentheses together. Now, each one of these parentheses has two terms in it, right? Because terms are separated with pluses and minuses. So 4w is one term and 3f is the other. So two terms here, two terms here. When you have two terms, you're called a binomial. So that's why this FOIL acronym is what a lot of times you'll hear people say when they're multiplying two binomials together. They'll say, oh, we need to FOIL this. What the F stands for is first. So when you're multiplying the first terms together, what that means is the first term of the first parentheses with the first term of the second parentheses. So I have 4w times 4w, which gives me 16w squared. Right? 4 times 4 is 16. W times W is W squared. So now, the O stands for outer. What the outer is saying is the farthest most outside terms of the problem, which means this one times all the way on the other outside that one. So that's what you're multiplying next. 4w times negative 3f. So let's see. When you're multiplying letters, and if they're not the same letter, they're just going to hook on to each other. So I've got 4w times negative 3f. So let's see. This negative 3 times 4 gives me negative 12. Now, WF. Okay, now before I write this down, negative 12, WF. Anytime you are multiplying letters together, it doesn't really matter which order you put them in the answer part of it, but I'm going to put them in alphabetical order always because it's easier to see alphabetical order who is like terms. Okay, so I've got negative 12, WF. I'm going to write that as FW, just to put it in alphabetical order. And you'll see why in just a second. So I've done my outer. So first outer, the next thing is going to be inner. What that means is the most inside terms of the whole thing. So now I have a positive 3f times a positive 4w, which gives me positive 12fw. Again, that's why I put them in alphabetical order, fw. Then my last, which is what the L stands for, means the last term of each parenthesis. So the last term of the first parenthesis times the last term of the last parenthesis. So I've got positive 3f times negative 3f, which gives me negative 9. And then what do you get when you multiply f times f? F squared. So let's see now, after you do the FOIL, which again, the first two things are the 4w goes here and here. Then you start over with the 3f, and it goes to both of those. So first, outer, inner, last. Once you do this FOIL, then you're looking for like terms. A like term that would go with this one would be a W squared. There's not any other W squareds. A like term with this one would be another FW. There is another FW, which means these two are like terms, which you see a lot when you FOIL. Those middle two terms right here are all a lot of times going to be like. Now this one's a special case because since they are like terms, that means I do put them together. And this is negative 12 FWs and positive 12 FWs. Negative 12 plus 12 is nothing, which means these cancel each other out all the way. And then I have the minus 9F squared. So your answer is just what is left, which is the 16W squared minus the 9F squared. Okay, so that's what the FOIL is going to be. All right, the last three are some more FOIL. First, outer, inner, last. Number 21 says S minus D times S minus D. So I'm going to do first, outer, inner, last. So my first, would be first term in the first parentheses times first term in the second. So S times S gives me S squared. My outer, remember outer is the farthest outside two terms. So I've got S times negative. First of all, don't mess up on your signs. You got a positive times a negative. That automatically means your answer, that part is going to be negative. Because you've got positive times negative. So I've got S times D. Now remember, I'm going to put those in alphabetical order. S times D. So I'm going to put that as DS. Then my inner, look what I have again, another negative times a positive. A negative times a positive gives me a negative. D times S, again, if I put that in alphabetical order, it'll be DS. And then the last, negative times a negative. Negative times a negative always gives me a positive. And then what do I have? I've got D times D, which is D squared. So let's see. Again, a lot of times after you FOIL, the middle two terms will be like terms. So let's see. These do not cancel out like the last problem. The last problem canceled out because I had a positive 12 that I was combining with a negative 12. Positive 12 and negative 12 combines to cancel out. But this is a negative 1 and another negative 1. When you put negative 1 with another negative 1, remember, you're adding now or subtracting. That gives you negative 2. So when I put these two terms together, negative 1 DS here, and I put that with another negative 1 DS here, now I've got negative 2 DS's. So I've got S squared, put these DS's together to get negative 2 DS, and then plus D squared. Number 22, x to the third plus 7 times x to the third minus 6. So I'm going to FOIL. So my first, x to the third times x to the third. Remember, if you're multiplying the same letters together, you're going to add their exponents. So let's see, x to the third times x to the third gives me x to the sixth. My outer, what do I have here? I've got a positive x to the third times a negative 6. So a positive times a negative gives me a negative. X to the third times 6 is just 6x to the third. My inner, positive 7 times x to the third just gives me positive 7x to the third. And my last, I've got a positive 7 times a negative 6, which gives me negative 42. Again, look at your middle terms. They are both x to the thirds, which means you can put them together. So I'm just going to drop down my x to the 6. You can't put terms, even if they're both x's, they have to have the same exponent. They have to be all the way the same kind of term. You can't put an x to the 6th with an x to the third. You can only put x to the thirds with other x to the thirds. So this x to the 6th just comes down. Here I've got negative 6x to the third plus 7x to the third, which gives me positive 1x to the third. And just bring down the minus 42. This 1 right here is not necessary. It shouldn't mark it wrong because it's not wrong. It's just that when you have 1 of 1x to the third, it's just the same thing as saying x to the third. All right, last one, number 23. I've got c squared minus 4g squared times c squared minus 2g squared. My first, c squared times c squared. So remember the same letters that you're multiplying, which means you're going to add their exponents. C squared times c squared gives me c to the 4th. Outer. Here I've got c squared times negative 2g squared. Let's think about our sign first. You've got a positive times a negative, so we're going to make that for sure be a negative. Let's see, my numbers are going to give me negative 2. Now, I'm multiplying a c squared times a g squared. Those are different letters, so you're just going to hook them together. So you're going to have c squared, g squared. Right? You can't add their exponents because they're different letters. Then to the inner. And once again, you'll notice I put the c and g in alphabetical order. So let's see what I have here. I've got negative 4g squared times positive c squared, which gives me negative 4. Put your letters in alphabetical order. I've got a g squared and a c squared. So I'm going to put that as c squared, g squared. And then my last, negative 4 times negative 2. A negative times a negative gives me a positive 8. Now my letters are the same, right? I've got g squared, g squared. So if I add those exponents, I get g to the 4th. Again, your middle two terms, once again, are like terms. So you're putting your terms in the same basket. They're both c squared, g squareds. So then you just combine them. So I'm just going to bring down that c to the 4th. If I put my c squared, g squareds together, I've got negative 2 here and negative 4 here. Remember, I'm not multiplying anymore. That was up here. Here, I'm just combining like terms. A negative 2 and a negative 4 is a negative 6. C squared, g squareds. Drop down my plus 8g to the 4th.